All right, so we're going to work on an example in the lessons that we're working on now. It's going to be about writing and solving two-step equations. So we have already in the past written and solved for equations that we have created, but now it's going to be a two-step equation that we're looking at. So the example that they've given us is Mackenzie drives the same distance to and from school each day. She also drives 1 3/4 miles round trip to go to the library. During a 5-day school week, Mackenzie drives a total of 50 miles. We need to write and solve an equation to determine the total distance to and from school. All right. So first things first, when you're looking at a word problem, you want to probably read it maybe 2 to 3 times so you can really understand what they're asking. So a couple things stood out to me. I noticed that she is going the same distance to and from school each day. In addition to that, she's also going an additional 1 3/4 mile round trip each day to the library. So we're going to find out during the 5 day school week how many miles she is driving. All right, so let's look at that. This tells me, let me see, she's driving the same distance to and from school each day. So we're going to call that X. That is the number of miles that she's driving to school and from each day. In addition to that, she's also driving, so addition, she's driving 1 3/4 miles. So remember that 1 3/4 is the same thing as saying 1 3/4, right? So one is our whole number, 3/4 is our fraction. Oh, sorry. I don't know what I just wrote. 1.75, sorry. Um, so we see that we have one for our whole number. Your fraction is going to become your decimal equivalent. And so 3/4 is the same thing as 7,500. So I'm just going to add 1.75. I prefer to work with decimals if I can over fractions, but it's all about preference. All right, so we know that she's going to travel X plus 1.75 miles, and she's doing this 5 days a week. So we're going to multiply that by 5, and then that's going to be equal to 50. All right, so now what we're going to do is we're going to use the distributive property um, to simplify this expression. So this becomes 5 times x, that's 5x. And then this is 5 times 1.75. So let's see, 5 times 1.75 gives me 8.75. So plus 8.75, and that is going to be equal to 50. Okay. So now what we need to do is ask ourselves, is our variable isolated? I see that it's not isolated. So let me just look and go back to PEMDAS. And because our variable, we're not solving an expression, we actually have the equation. The variable needs to be isolated. So we're going to use PEMDAS, but in reverse order. Remember, if we're adding or subtracting, we need our value to become 0, so our sum or our difference. And if we're multiplying, we need our product or our quotient to become 1. All right, so working our way back, I see that x is not isolated because it's being multiplied by 5. And then in addition to that, we're adding 8.75 for us to get 50. So I'm going to subtract 8.75 from both sides. Okay, and by doing that, we end up with 5x. The 8.75, the positive and the minus for the same quantity becomes 0, which is good. And that is going to be equal to, let me see, if I took away 9, that would be 41, and then add a quarter, so 41.25. Okay. All right. So now we have S times X is going to be, I'm sorry, 5 times X is equal to 41.25. I'm going to divide both sides by 5. Okay, and by doing that, that's our multiplication and division. We need that to become 1, so we're left with 1x. That is going to be equal to 41.25. Let's see, 41.25 divided by 5 gives me 8.25. So that is equal to 8.25. If you kept it in fraction form, you'll also come out with 8 and 1/4. Okay, so this is one of the ways that you can solve it. If this makes sense for you, you can stop the video here. In one of our other videos, I started to show you how you didn't necessarily have to expand an expression for you to solve it. So I'm going to show you another way that you could have solved this. And it's going to be a little faster, but remember, you can always pause, rewind, or whatever you need to do. So this is the answer up here, 8.25 or 8 1/4. All right, so now what we have is going to be, let's see, 5 times x plus 1.75, and that is going to be equal to 50. Okay. What I could have done is looking at my expression or my equation, I noticed that the variable is not isolated because it's being added where we're adding 1.75, but we are also multiplying this expression within the parentheses by 5. So in other words, we have 5 sets of this. So if I'm using PEMDAS like we did before, okay, we're looking and seeing what operations is happening, right? So we notice that there is no addition or subtraction outside of the parentheses, right? So then we move into multiplication or division, and I see that we are multiplying by 5. So what I could have done was divided both sides by 5, and then I am left with x plus 1.75 is going to be equal to 10, and then I could subtract 1.75 from both sides, and then x would be equal to 8.25 or 8 1/4. So it's the same. It's all about preference. So whichever way works for you, that's fine. But I did want to introduce you to that to let you know that you don't have to use the distributive property. You can actually go on and just start from the multiplication inverse, which would be division for you to get rid of that 5 outside of the parentheses.